The game is played by spinning two 5-sided spinners numbered 1 to 5. The numbers are added together. A player can pay P dollars to play the game. If the total is 2 or 10, the player wins $10 and gets their stake back. If the total is 3 or 9, the player wins $5. Now here's the change. In your test that said $9, and that's a fundamental flaw that stops us being able to do Part C and F. I don't know why that had been changed. My solutions were actually with the $5 in, and so I just don't know why it was there, and I do apologize, but in actual fact it didn't really do anything to the marks because parts E and F were very difficult anyway. So if the total is 4 or 8, the player gets their stake back. Any other score results in a player losing their stake. Now this getting the stake back really caused a lot of problems. But let's start off with the spinners. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We know we're going to add them. So 2, 3, 4, 5, 6. And then we've got 3, 4, 5, 6, 7. And 4, 5, 6, 7, 8. 5, 6, 7, 8, 9. And 6, 7, 8, 9, 10. So a distribution of x, and then we've got the probability x is x, and we can see we've got values 2, 3, 4, 5, 6, 7, 8, 9 and 10, and the probabilities are all out of 25, so it's 1 out of 25, 2 out of 25, 3 out of 25, and the 6s are the most, aren't they? So it's 4 out of 25, 5 out of 25, and then it goes down again. So 4 out of 25, 3 out of 25, 2 out of 25, and 1 out of 25. The random variable y is defined as the total won by a player per game. Now, here we have y, and the probability of y being y. The player can lose their stake. They can get their stake back. They can win $5, that was 9 in your test, or $10. Not 5 plus P or 10 plus P or any of that business. If you give your stake in and then you get it back, you're at 0. And it does say here they win $10 and get their stake back. Now the probability of winning 10 is going to be these two values. So that's 2 out of 25. To win 5 or 9 in your test, that's going to be these ones. So that's 4 out of 25. They get their stake back for these ones, so that's 6 out of 25, and then this has to add up to 1, or we add these ones, giving us 13 out of 25 here. Now, despite some people getting this wrong, this next part was very well followed through on. The expectation of y is going to be negative 13p over 25. This is just going to be 0. And then we've got 20 over 25. Of course, that was 36 for you. And another 20 over 25, so that's going to be 40 over 25. You can see how this is going to work for the figures that you had. So that is the expectation of y in terms of p. We could perhaps put it over a single fraction, but there were no marks for doing so. What value of p would result in the game being fair? Well, we want the expectation of y to be equal to 0, which means that negative 13p plus 40 must be equal to 0. So 13p is going to be equal to 40. So p is 40 divided by 13. and that would be basically $3.08. Now, unfortunately, with the 9 I gave you, this ended up being more than $4, which is why this doesn't make any sense. And that's why I removed these two parts. So, if the owner of the game charges $4 for a player to play, how much profit would they expect to make from 100 plays? So we're just going to put p equals 4 in here. So we've got negative 13 times 4, add 40, divided by 25, and then multiply that by 100. So let's do that. Let's just put some brackets around that. So we've got negative 13 times 4, add 40 over 25, multiply that by 100, that's negative 48. So they would expect to win 48. Remember, this is from the point of view of the player, so they would lose 48. The owner wants to increase the $10 prize as much as possible while charging $4 per game. What is the greatest prize for getting a 2 or a 10 that can be given without the owner making a loss? Well, that needs us to go back to our table for y. And the probability y equals y. And we now know this is negative 4. And we have 0, 6 over 25, and we've got 5 with 4 out of 25, and then we don't know what the winnings are going to be. 2 out of 25. And basically, we just want expectation of y to be equal to 0. We want to put it back to being fair. So we're going to have, so 4 13s are 52, so we've got negative 52 over 25 plus 20 out of 25 plus 2w over 25 is equal to 0. So 2w, take away 32 equals 0, so 2w equals 32, giving us that w is $16.